Topic 2. Linear motion.
At the end of this lesson, you should be able to discuss the physical meaning of displacement time graph, velocity time graph and acceleration time graph.
Graphs give a visual picture of the manner in which one variable changes with another. Looking at motion graphs can help us to see what is happening over a period of time. There are three types of linear motion graphs: first, displacement versus time graphs; second, velocity versus time graphs; and third, acceleration versus time graphs.
Displacement time graph. In this graphs, notice that time is going to be on the x-axis and position on the y-axis. The different shapes can tell you if the object is accelerating, at rest, or moving at a constant velocity. From the displacement versus time graph shows that the displacement of a body increases uniformly with time. This shows constant velocity. The magnitude of the velocity is equal to the gradient of the graph, where gradient is equal to delta x over delta t, and this is just the expression for velocity. The image below shows you how the line of a graph changes depending on the type of an object's motion. The first graph shows that the object is at rest, which means that its speed is not increasing and is not decreasing, it is just staying in the same position. The gradient is 0, which means that the velocity of the object is 0. The second graph tells you that the displacement of an object is increasing uniformly with time. This shows constant velocity. The magnitude of velocity is equal to the gradient of the graph. The third graph shows an example of body's velocity steadily increasing with time. To find the velocity at a particular instant, or the instantaneous velocity, we draw a tangent to the graph at the relevant point and calculate the gradient of that tangent. Velocity versus time graph. The velocity time graph, with y-axis denoting velocity and x-axis denoting time, as shown in the figure. The gradient of a velocity time graph is the change in velocity divided by the time taken. It is equal to the magnitude of the acceleration. The displacement is equal to the area under a velocity versus time graph. This can be clearly seen in these graphs. The shaded area is equal to displacement of an object. Velocity versus time graphs tell us about an object's displacement. Graph A. The velocity is constant throughout the time interval. In this case, we have taken the initial velocity to be positive and the magnitude of acceleration is 0. Graph B shows the velocity of the object will increase linearly with respect to time. The gradient of the graph will give the magnitude of acceleration. Acceleration versus time graph. Following are the points understood from the graph. If gradient is 0, then the motion is said to have constant acceleration. The area under the graph represents the change in velocity.